So Schiper-Eggli-Sandoz algorithm. This algorithm is not a broadcast based, but it is unicast based, in which each process used to maintain a vector, and that vector includes its timestamp as well as uh, the process to which the message is being sent. So initially, when the vector is being empty, because if there is no process, the vector remains empty. We have uh, certain things which is being associated with the maintaining of the timing related local timing as well as the present clock timing. So how it works, it all depends upon uh, it, there are two conditions which used to happen in SES algorithm. One is sending of the message and another is the delivering of the message. Sending of the message doesn't mean that it is being delivered at the time whenever it is being sent, because the process which is going to receive any message from any other process, first of all it will try to look that whether there is any message preceding to that message which is required to be delivered, and if it is so, it will delay that message, and first it will try to receive those messages which are sent before that. So as far as the sending of the message is concerned, whenever a message is being sent, so message is being sent along with its timestamp as well as the vector which is being maintained by the process P1, which it wants to send it to the process P2. And then it try to insert some value into its vector just by overwriting the previous values if there is existing. Now, the whatever value it is going to replace, that value is not sent, because the value which is being sent in the form of a vector from the process, which was the previous happened uh, events, the information related to the vectors, which includes the previous related events, that will be accompanying with the message. Now, as far as the delivery of the message is concerned, whenever it is being delivered, delivering is required to be buffered if the time at which it is being received is not less than or not less than, and else it is being delivered. Of course, it will be more clear whenever we will go with the example. And the SES algorithm, the first example is shown here, in which we have a three process P1, P2, and P3. The initial vector which is being maintained by P1, P2, P3 is 0, 0, 0. I have already mentioned, it is already mentioned that the vector three components in this vector is being maintained, where the first component belongs to the process P1, second component belongs to the process P2, and the third component belongs to the process P3. So in this example, suppose P3 process has initiated certain event of sending a message at E31, and it wants to send this message which is occurred at this particular moment of time at this event at P3. It wants to send this message to P1. So for sending this message to the P1, it is necessary to maintain a vector over here. Now, since this is the first event which is occurring at P3, so the timestamp will be incremented, and it will become 0, 0, 0. It will become 0, 0, 1. Why it is 0, 0, 1? Why not it is 1, 0, 0, or why not it is 0, 1, 0? Because third component belongs to the process P3. So it is the first event which is happening in the process P3. That's why this 0 will be incremented, and it will become 0, 0, 1. So the timestamp of this particular event is 0, 0, 1. Now, what the event is to send a message from P31, means the process P3, to the process P1. So it also maintains a vector that is giving the information that to which process this message is being sent. So P1 is the process to which P3 wants to send the message. So here in the vector, it will maintain P1. along with the timestamp at which the process P3 is sending this message. So it will maintain two things 001 as well as the timestamp and the vector as P1001. Now, whenever this message is being sent, it is not necessary to send P1001 along with this message. Only timestamp will be going. Why? Because it is the first event which has been occurring at the process P3. And before that, since it is 0 and it is 1, it means P3 is able to know that before this, there is no message which has to be received by P3, or there is no message which the process P3 has initiated before the E31. So that is why it is not necessary to send this vector value along with this message. Only timestamp will be going along with the message, and it will be received here. Now, after E31 is being occurred at the process P3, P3 has initiated another operation, another event, that is E32 after a certain time. So when this second event is going to occur at the process P3, this timestamp will be changed, updated. And since it is the second event, so 1 will be added into the third component of the vector of the timestamp. So it will become 002. Why it is 002? Because it is the event which is initiated by the process P3 after the E31 event. So the timestamp will become 002. And at this event, it wants to send a message to the process P2. No problem. So now it will maintain its vector. What vector? The vector which includes P1001, giving the information, having the information that before this event, there was an event which has occurred. And with that event, process P1 has been sent a message with the timestamp 001. And now this is the second event. So say second event is to send a message to the process P2 at the timestamp 002. So it will also maintain P2002. While sending this message, which is a kind of an event which occurred at process P3 at E32, whenever it has to send this message, it will send two information. The first information is related with the timestamp, that is 002, and the second one is only P1001. Since P3 is sending a message to the process P2, so there is no need to send this value, this vector value P2002 to the P2. But it is necessary to send P1001 vector information along with this message to the process P2, so that P2 should be able to know that an event has already occurred at the process P3 for sending a message M from P1 with the timestamp 001. Now this process P3 has sent a message which is being received by process P2. Why it is going to be received by process P2? Because process P2 is initially it is 001. So when with this timestamp, this process is sending its vector value to this one, it means P2 will be able to know that there is no message before preceding to this message which is sent from me. There is no other message preceding to this particular message to the process P2. Because if there is any message preceding to this particular message which is sent by process P3 to P2, it must be informed by the process P3. And that is why, since it is 0, so that is why, since it is 0, the initial vector value is 0, so it will remain. So it is going to be received by the process P2. Whenever process P2 is receiving this message, it will update its timestamp. How it will update its timestamp? Now the second component of this process P2, second component belongs to the process P2, and this is the first event which is occurring at the process P2. So this second component 0 will become 1. And since the timestamp which is received by the process P3 is 2, so it will be 2. And it will be 0, and it will 0, so it will be 0. So the maximum value which we have to take, 0, 0, maximum 0. 0 will become 1 just because that it is the first event occurring at process P2. And the maximum of 0 and 2, it will become 2. So the timestamp of process P2 of receiving this message will be 0, 1, and 2. Along with that, it will also maintain a vector. Previously, it has not maintained any vector, but now since it has received a message, and so it will maintain a vector with the value P1001, which has come along with the message. So it will store P1001. Why it is required to maintain a vector P1001 at the process P2? Just because if process P2 is sending any message to the process P1, it will give the information, the message will be carrying the information that before sending any message, there is a message with timestamp 001 has been sent to the process P1 by another process. So after this message is received and after the timestamp has been updated and the vector has been maintained, there was a second event which is happening at the process P2. That event is E22. At this particular event, the message, another message is required to be sent by the process P2 to the process P1. But before it is going to do, first of all, it will update its vector clock timestamp. It will update it. How it will be updated? Since it is the second event, so this 1 will become 2, this 1 will become 2, and since it is the second event of this, so 1 will become 2, and maximum of 0 and 0, this will be 0, and maximum of 2 and 0, that will be 2. So this timestamp will be 0 to 2. As well as it will also maintain that since it is a sending process, the event is sending a message to the process P1. So what it will do, it will replace this value by P100022, because it is an event which is trying to send a message at the E22 to process P1 with timestamp 022 with P1022. Now this value, this vector is being maintained by process P2. But while sending the message from E22 to the process P1, it will send this timestamp, but it will not send this value. Why this will not send? Because previously stored value, which is P1001, because P1 is more concerned about its knowledge that how many messages preceding to this particular message has been already sent to the process P1. So that is why instead of sending P1022, it will send a message with the timestamp 022, because right now it is time 022, and the previously received vector, that is P1001. Now when this P1001 and 022 timestamp, the message is being sent to the process P1, P1 is not going to receive it. Why it is not going to receive it? Because it is already carrying a vector value, that is P1001, which indicates that process P1 has to receive a message before this message, because 001 indicates that process P3 has initiated a sending of the message event to the process P1 with this vector value. Since the initial vector value is already 000, so this message which is being sent from the process P2 will not be received. It will be buffered. Why it is buffered? Because it will be received if and only if the value of the event, mean the timestamp, the vector value of this process P1 should be at least 1, because P3 has already sent this message. So this message will not be delivered at this particular moment. So what will happen? P1 will wait till the message M, which is being sent by the process P3, has been received. And once this message is being received, it will update its timestamp. How it will update? Now, since it is the first event which is occurring at the process P1, so this 0 will become 1. Now, the maximum of 0 and this 0 will be 0. So here it is 0. The maximum of 1 and 0, that will be equal to 1. So now the timestamp of the process P1 at this particular moment will become 101. Now, this message is not being received until the timestamp of the process P1 is greater than the timestamp of this value. Now, the timestamp of P1 is 101, which is now greater than 001. Now, after this, this will be received. So this is called the buffering of the message, and delivering of the message is being delayed just because of this information. If this message is not carrying this information, then there will become the inconsistency of the receiving of the messages. Because since this message was initiated first, so this message was initiated first to be received by process P1. So this will be received first, because after this event, E32 has occurred, and this has derived this event, this has derived this event, and this has initiated another message. It means this message is generated after this message. So this is the information which has to be carried out and required to be buffered. This P1 must know that what is the value with which it is receiving. So this has to be buffered, and it has to be delivered only after the receiving of the previous message. Let us go with the another example, that is uh, uh, with the help of SES algorithm. Now, in this example, again we have three processes: P1, P2, and P3. The process P2, process P1, initially it is 0, 0, 0. Here it is 0, 0, 0. Here also it is 0, 0, 0. So in this example, process P1 is initiating an event at E11 by creating a message and sending that message to the process P2. So it will maintain two things. First is the timestamp, and then second one is the vector with the timestamp. So timestamp will be, since it is previously it is 0, 0, 0. So the first component belongs to the process P1. So this will become 1, and the rest value will become 0. So the timestamp of this event is 100. So while sending this, the timestamp is 100. And since it is sending this message to process P2, so it will also maintain the vector P2 with this timestamp 100. Now this process sent. Now while sending this message to the process P2, it will send only the timestamp, not this value, because since the process P2 he has to receive this information, then in that case 100 will be carried, and this is not required to be carried along with the message. So the message, whenever it is being received at the process P2, it will update its clock time, and its clock time will become, since it is the second event which is first event which is happening at the process P2, so this middle component will become 1, and then this higher component, first component is 1 and it is 0, so the maximum of this is 1. The maximum of this 0 and 0 will become 0. So the timestamp will be 110. Now, at this particular instant, the second event has occurred at the process P1, and this is the event in which it is trying to send a message to the process P3. So first of all, it will update its local clock. So this is the second event, so it will become 200. Since the first event has already created, first event has been done by the process P1, so it is P210, so P2100 will be maintained. Along with this, since it is sending a message to the process P3, so it will also maintain the process P3 with the timestamp 200. Since process P1 has initiated to send the message to the process P2 with the timestamp 100, so it will remain 100. And since E12 has been the event which is initiated at the vector at the timestamp 200, so second vector which will be maintained is P3 200. Now this is being sent to the process P3. Now when the process P3 will be when the process P1 will be sending this message, what kind of information it will be sending? It will be sending the timestamp 200, and it will not send P3 200 to that P3 because this message is meant for P3, so no need to send this process P3 200, but it will send this information which has previously happened event in the process P1. So it will send P2 100 to the process P3. So when it is being received by the process P3, it will update its timestamp. Since it was here 2000, so the first value is 000. So first value is 2, and here it is 0, so it will become 2. The second component is 0. Here it is 0, so it is 0. And the third component, which is the component of the process P3, since it is the first event which is occurring at the process P3, so it will be incremented and it will become 1. So timestamp of receiving this will be 201, and it will maintain P2100. Now the second event is occurring at the process P3. So when the second event is occurring at the process P3, the first thing is to update its clock. How it will update? Since it is the second event, so 2 will remain 2, 0 will remain as it is, because there will be no change in this value, because it is the event which is occurred at the process P3. So this 1 will become 2, because the third component belongs to the process P3. So the timestamp will be changed, it will be 202. And at this event, it has created a message, and this message has to be sent to the process P2. So it will maintain a vector P2 202. So it means this value is replaced by P2 202, and with this value it will be sending to the process P2. But whenever it is sending this at event E32, it is sending a message. It will not send P2 202, but it will send the previous value which has been received by process P3 from the process P1, which gives the information of the previous happening of the sending of the message. So instead of sending P2202, it will send P2100. So this will carry the timestamp, current timestamp, that is 202, along with P2100. So this message is to be delivered at this particular juncture, but it will not so. Why it will not so? Because because this is the first event which is going to occur at this moment of time, and already it is initialized vector with 000, and with this initialized vector, whenever it is going to compare with 100, since this value is greater, so it is not going to be received over here. So this will be received since it is the timestamp is supposed 202, and here the timestamp is 000. So since 202 is greater, so it will not be able to receive it, because see, here the second component belongs to P2, and here the second component is 0. So, and the rest of the value is greater, so it will not be received until unless this value is going to be greater than this value. This will not be able to receive it. So what will happen? This message will be buffered till the time when the first message will be received by the process P2. Now the purpose of sending P2100 to the process P2 is very simple. It says, it gives the information to the process P2 that this 1 represents that process P1 has initiated a message previous to this particular message at a particular moment of time, and until this message which is generated by process P1, which is represented by this 1, for the process P2, until it is not received, this message should not be received. So when this message is being received, then only this message will be received, and until this message will be buffered and delivered after that. And why it is delivered after that? Now when this message is being received, so what will happen? It will update, since it is the first event happening at the process P2, so second component will become 1. The maximum of 1 and 0, it will become 1. the maximum of 0 and 0, this will become 0. So the timestamp becomes 110. So till this value is greater than this value, this message will not be delivered. Here the value is 000 and here the value is 100. When this value becomes 110, which is more than 100, then only this message will be delivered. And whenever this message is being delivered, the timestamp is 202. So the timestamp will become, since it is the second event which is happening here, so 1 will become 2. Maximum of 1 and 2 will become 2. Maximum of 0 and this 2 will become 2. So the timestamp become 222. Now this is another buffering example which seems to be similar, but there is certain explanation. The process P1 is initialized vector is 000. Process P2 has initiated some message. So previously its vector was empty, means 000, and it will maintain its time, and the timestamp will be 010. It has sent this message to this particular, so it will be received by this one. Why? Because it is 000, the first value is 0 and it is 0, so this can be received. And whenever it is being received, the first value will be updated and it will become 1, similar to the previous value. Now let me give you the explanation of that. M1 from P2 to P1. M1, this is the message M1 from P2 to P1. So what it will be doing? It will be sending M1 the message itself along with its timestamp, that is 010, as well as the empty VP2, because this is empty, it is not being maintained, because it is the first event which is happening over here. So this empty means no information is given. Now the second message, M2 from P2 to P3, M2 from